I'm Dan Frankowski, and I work with Google Groups. And I did this work at GroupLens Research at the University of Minnesota with Tony Lam, Shalad Sen, Max Harper, Scott Yillick, Mike Cassano, and John Riedel, a cast of thousands. And I published a paper and gave a talk similar to this at WikiSim 2007. And it's called Recommenders Everywhere, the WikiLens Community-Maintained Recommender System. This talk is about beer. Yes. Finally. Actually, it's about a beer lover confronted with many beers. And we try to answer the question, how can we help him decide which beer to drink? The answer that we propose is WikiLens. This installation has been running on wikilens.org, and it has hundreds of users and thousands of items and beer. But before jumping into the details, I'd like to tell you a little bit about what motivated us to build this tool, the principles, the high-level principles we used to organize our thinking, the design of the features of WikiLens, our experiences with it, and some possible improvements to it. So there are many popular websites that are fueled by user contribution. Amazon has millions of customer reviews. MySpace is a social networking site, but it has hundreds of thousands of user-uploaded videos. And of course, Wikipedia has millions of user-edited encyclopedia articles. And the list goes on of popular websites fueled by user contribution. But sometimes it's hard to find the treasure in the trash. A personalized recommender system recommends items based on your personal preferences. So if you tell Amazon what you like, or you buy some things on Amazon, it'll give you a list based on those things, using facts like 80% of people who bought this item also bought this item, or who browsed this item also browsed this item. This is an example of a collaborative filtering algorithm, and there are several of them, combining ratings of users like you, combining ratings of items similar to those you rate. And such algorithms often require many users and many ratings. Here's another recommender system, and I'll introduce it because I'll talk about it later. This is MovieLens. It's run by the GroupLens Research Group at the University of Minnesota, and you rate some movies, and based on your ratings and the ratings of others, it recommends other movies to you. It has thousands of active users. It has 13 million ratings, which is very large for a research system, but no beer. So suppose our beer lover wants to start a community site. He could start a wiki or a forum or a blog, but what if he wants to start a recommender? And what if he wants that recommender to be fueled by community contribution? We propose community-maintained recommenders where users contribute all the content and the information needed to recommend that content. And since traditional recommender algorithms need many users and many ratings, but most online communities are small, we propose small world recommenders. These systems would have to provide user value even with very little preference data per item, and they do so by depending on the users of the system to understand other users deeply. For example, by seeing other specific individuals' preferences. We still think it would be important to aggregate user preferences into recommendations. Imagine going to a movie with 5 of your friends. It's still hard to find a movie that all of you will like, or at least none of you will hate. So what is this small world like? Well, its users are passionate. In 2002, there was a TV series called Firefly. And when it looked like it was going to be canceled before the series was over, people organized themselves, calling themselves browncoats, holding parties, making websites, and even gathering money to take out an ad in the New York Times. The series didn't appeal to the mainstream, but it appealed to a small group of people very strongly. These people want community maintenance. This is the administrator of Anime Planet, and he said, I currently spend about 70 hours a week, all of my free time, working on this site, and I can no longer do it. I need other people to help. And they want recommendations. One of the major features of this site, Anime Planet, is a recommendation database. So we looked for an existing system that we could use to set up a community-maintained recommender and study it. And we found libraries, we found web services, and we found research into recommenders, but none into community-maintained recommenders. So we built WikiLens. And although this talk is about beer, as I promised, WikiLens supports more than just beer. As we were developing WikiLens, we didn't advertise it very much, but people still started to ask us if they could use it because they have a desire to offer recommendations on their site, and there are no tools to allow you to easily do that. So we take this as some support that there's desire in the small world for such a tool. So let me describe a few principles that we use to organize our thoughts. Why do you care? Why do you care about principles? That's what I always ask in a talk. Why do I care? And in this case, there are lots of features that you could add to a system, and we want some way to organize our thinking. Furthermore, perhaps you're not going to take WikiLens yourself, but you're a system designer, and these principles could influence you in building your own system. So suppose our beer lover goes to find a beer. He Googles, of course, and finds a website called beeradvocate.com. He finds on that site the top 100 beers. And the one at the top is one that I can't pronounce, called Trappist Vestvleteren 12. How does he know if he'll like Trappist 12? Well, it's in the top 100. But Beer Advocate also has the top 100 American beers, the top session beers. I don't even know what a session beer is. And the strongest beers. Clearly, these multiple lists might appeal to multiple people. Indeed, each person might want their own list. But no matter how much our beer lover tells Beer Advocate about their preferences, this list will never change. It's not personalized. Beer Advocate has 32,000 beers. But what if you and your friends can't drink that many? You want to find the ones that you'll like. Similarly, Anime Planet has thousands of works of anime. You want to find the ones that you'll like. So our first principle is find. Members should be able to find items that interest them. And without going into detail, I'll just say that researchers have looked at how people find items of interest, and it's complex. So suppose we found some beers we like, and our beer lover wishes to add his favorite microbrew at the pub down on the corner. Well, at Beer Advocate, you can't add a beer until you've reviewed at least 20. But Chris Anderson, who wrote a book called The Long Tail, says, the market for books that are not even sold in the average bookstore is larger than the market for those that are. So there's a lot of interest in these microbrews. And here's an example of our own sort of microbrew on wikilens.org. Michelob is a large brand, but apparently Golden Draft Light isn't available everywhere. People commenting on this page say, I wish it was sold in Montana. You can't get everything in New York. And someone who obviously disagrees with these fanatics say, are you people insane? Well, maybe they are. They're in the small world. Moreover, people work harder for immediate satisfaction. One of the big complaints on MovieLens from its users is that it doesn't have the movies that the user wants to rate. It doesn't have my movie, says the movie fanatic. So in 2005, Dan Cosley ran an experiment with MovieLens users where he allowed them to add movies. And he separated them into multiple experimental groups. One group got to see the results of their addition immediately. Another group got to see the results of their addition only after someone else reviewed it. And people who saw the results of their addition immediately did more work. So our second principle is add. Members should be able to add items immediately. So our beer lover wants a beer-centric system, of course. And there's information common to each beer, like its style or alcohol content. So here's Beer Advocate's beer detail page. Has alcohol availability. Suppose we want to edit this detail page. No chance. And suppose we were to add a field. We want to add color, dark or light. You can't do it. The site is owned by Beer Advocate. Well, so people say, if you want to offer a database of items, why not use a content management system? In general, lots of these content management systems support fields, structured data, but they don't support the add principle, being able to add or edit items immediately. And if people have found if you give power to the people, the community can do amazing things. Wikipedians change display templates, they categorize items, they build bots and tools to clean or enhance data. So our third principle is deep change. Members should be able to uniquely identify items and define and redefine their attributes and organization. So let's rate a beer. Our beer lover goes to rate Two Hearted Ale from Bell's. Well, apparently first you have to learn how to review a beer. You have to learn more about this style, American IPA. You have to fill out at least 6 drop-downs and a text box, which I couldn't fit in this screenshot. Now, I don't know about you, but I'm getting tired, and now I want a beer. But MovieLens users say rating is fun. And Bryant and Forte, when interviewing people who were very involved in Wikipedia, found that many of them started with small tasks, correcting punctuation and the like, and that these small tasks might be a path for a casual contributor to become a more involved contributor. So our fourth principle, micro-contribute, is that members should be able to make small contributions. And any community site will allow you to see other users. Here's Phage Lab reviewing a beer. In fact, when you think about it, think about it for a second. If you look for movies to see, books to read, you ask your friends, what did you see? What did you read? In fact, Tom Erickson thinks that every collaborative system should allow you to see other people. He calls it social translucence. So our final principle is see others. Members should be able to see each other and their contributions. Well, so are we just rebuilding Beer Advocate? Well, first of all, I don't know Beer Advocate very well. I'm just using it as an example because it's about beer. And we're sort of rebuilding it, but we believe that lots of small communities have these same needs that I've just outlined. And so there should be a tool that's general, that's not just about beer. It should allow anyone to start a new community, a new recommender community. It should give more power to that community, and it should have a personalized recommender. So let me talk about the design of our system, WikiLens. If you go to the homepage, wikilens.org, you'll see a link to beer, and you'll also see a few beers that are in that highly rated in that category. If you click on the beer link, you'll see all the beers in the category with predicted values. This system also has a social network, so you can propose being a buddy, and if they accept, then you're buddies of each other. And if they like a beer, if your buddy likes a beer, that is, if they rate it higher than their own average, you'll see it in the likes column on this page. A. Jolie likes Anchor Steam. B. Pitt likes Bell's Two Hearted. The predicted value is a weighted average of buddy ratings and the overall average rating. This is very unlike traditional collaborative filtering, and we did this for two reasons. First of all, I believed in buddies. I thought you'd want to know what your friends think. We also thought that traditional collaborative filtering algorithms would be too noisy with little data. And there are a few more details, and I'll let you see the paper. The classic cop-out. So here's a feature that supports our add principle. Any item is a wiki page. Here's spells two-hearted. And it can be added or edited by any user. A page is in a category, like beer, and a category can have fields, like style or alcohol content. Fields are specified on another wiki page with a simple language where you give a field a name, you specify which widget you'll use to edit it, and if it's a restricted option widget like a drop-down, it has options that you can list. Again, editable by anyone. Users edit fields with familiar widgets. So if you've said it's a radio button, when you edit a beer, you'll see radio button choices. Here's some features that support micro-contribution. This is Young's Double Chocolate Stout, which I like quite a bit, by the way. Perhaps not my favorite beer, but I like stouts. And you can rate the beer with smiley faces at the top of the page, the yellow things. You can also see your buddies' ratings. I've blanked out the names to protect the innocent or the guilty. It has fields, and you can edit the fields, like alcohol content in this case. You can add other information like links to sites or descriptions. And you can comment by typing in the bottom box and clicking Add Comment. Here's some features that support the find principle. You can select a beer by browsing through the system, searching, by visiting the category page that orders by predicted value. Once you've selected a beer that you are more interested in, you can evaluate it by looking at its details, predicted values, average ratings, buddy ratings, and so on. And you can see others. You can see your buddies. You can see their ratings on item detail pages. You can see whether they like things on the category page. And you can see other users. You can see their profiles. And if they haven't turned it off, you can see their ratings. You can see their comments. You can see averages. And you can see them in recent changes, like any wiki system, which raises a question. Is this a wiki or not? Well, any user can edit any page, any item, fields, field definitions, categories. Data, including fields, is versioned like in a wiki. It has recent changes in page history. But it's unlike a wiki in that you edit structured data fields with special editors. You rate things, and you have category pages that have items sorted by predicted value. So let me describe a few experiences that we've had with WikiLens. Almost everything I'll be talking about is one particular installation, wikilens.org, and the data was gathered over a couple of years. It has hundreds of users and thousands of items. That is small, but not minuscule. Here are the top 5 most popular categories. They have hundreds of items and dozens of distinct contributors. Our first lesson is that users will add items. 40% of the users who joined the site added at least one item. We found that broadening the community of contributors is useful. Each category's top contributor only contributed a few of the top-rated items. So for example, a user who I'll call MovieMaven added 70% of the movies, but only 3 of the top-rated movies. So here's a list of the top 25, the 25 top-rated movies, and MovieMaven added numbers 20, 21, and 25. That means other people in the community added all these things that are very popular to the community as a whole. Let me talk about MovieMaven just for a second. This user added over 1,300 movies. And if you conservatively estimate 30 seconds to add a movie, That's over 12 hours of work. Moreover, MovieMaven is also a member of the MovieLens site. And 97% of the movies that he entered were already entered in MovieLens and rated by MovieMaven in MovieLens. That is, the 3% of the items that he couldn't rate in MovieLens were sufficient motivation for him to support an alternative site, WikiLens, where people can add whatever they want. Another lesson is that users understand and change categories and fields. On WikiLens, we actually avoided adding a movie category. We already had a large and successful site that did that. But users wanted it and added it anyway. MovieMaven did not add the movie category, although he populated a lot of movies. This is another example that supports the deep change principle. I'm a part of a book club. This is not wikilens.org. And in our book club, we choose the next book that we want to read. Now, since I'm in the club, there's at least one user who knows how to manipulate the system, but we're able to put together an application that's useful for us. On the next book page, we have some information about where we're going to meet. By the way, if you're ever in Minneapolis, Gigi's is a nice coffee house. It says the order in which we're going to choose books. There's a category that shows all of the proposed books, but since one person chooses the book, they usually choose a few candidates from that category, and they put them on this page. We all rate them, and you can see who's rated them, what they've rated them. You can see comments, our own comments on whether we think the book is appropriate for the club. And I'll say, in this application, I mostly use the ratings for sort of veto voting. If anyone really hates the book, then I won't choose it. And so if you have the ability to build your own applications, you can tailor them to your own needs. We found that WikiLens supports a range of contributions. Most users who joined rated something. 40% of users added something, while fewer users changed category fields or categories themselves. Category pages were hubs of browsing. 6 of the top 10 pages browsed by logged-in users were category pages, like movie or album or book. We administered a user survey in November of 2006, and our users said they use WikiLens to find new items to learn more about. They find items by using the category page, and they evaluate items based on the predicted values on the category page. We found that traditional collaborative filtering is possible even in small data sets. As I said before, we used a very non-traditional collaborative filtering algorithm, but decided to simulate more traditional item-based collaborative filtering after the fact. We took 80% of our users as a training set, 20% as a test set. And for the test users, we used 80% of their ratings to generate recommendations and saw how often the other 20% came up, traditionally called recall. And we found that collaborative filtering improved recall even for the wikilens.org dataset, which is quite small by traditional standards. We found that buddies were used mostly by pre-existing social groups. Okay, by GroupLens. Although I had hoped people would bring in their own buddies to the system, it's very hard to start a new social network. Now, perhaps with Facebook opening up its social network for experimentation, or with Google proposing the open social framework, an application where you can get recommendations from your buddies might be more feasible. But in our system, it didn't go very far. So let's discuss a few possible improvements to WikiLens as it stands right now. Well, users use WikiLens to find new items, but if they don't have buddies, they get average-based recommendations. That is not personalized. So we should implement a personalized recommender for users who don't have buddies. And we would have to make sure that that recommender is suitable for the small world. That is, it's not easily thrown off by little preference data per item. Users used WikiLens to keep track of items I like or dislike, but organizing those items is hard. Right now, wikilens.org has 5 restaurant categories: Boston restaurant, Bay Area restaurant, New York restaurant. That doesn't scale. And so we should implement hierarchical categories. WikiLens.org could use more contribution, as any community-maintained site. And we'd like to make it more usable, more sociable, and give more incentives for people to contribute. And there's a lot of research into what exactly incents people to contribute. There are more people who want to install WikiLens than do install it. So we'd like to make it easier to install and change its look and easier to change its look and feel. It has templating, but it's complicated. There's kind of an interesting underlying point here. We made a tool that could be installed on the LAMP architecture, Linux, Apache, MySQL, and the P stands for PHP, but often Python or other scripting languages that can be plugged into Apache. So any tool that's not LAMP, we felt might be more difficult for people to install, might be less viral. However, it's hard to keep wikilens.org fast, and it's hard to keep it unbroken. So to keep it fast, often it's the recommendations that are slowing it down. And PHP represents a big challenge to speeding that up. We'd like to re-architect it for fast recommendations, possibly by having another component that's not PHP, but that potentially makes it harder to install. It's also harder to keep it unbroken, and several of us think that we should rewrite it in a type-checked language like Java, while at least one of our team members feels that that would be an abomination. So what have we learned in this talk? Or at least what have I hope we've learned? We propose community-maintained recommenders that support the small world. We want lots of beer lenses. We discussed 5 principles to organize our thinking and features based on those principles. We gave our experiences with wikilens.org, and it supported many of these proposals, but there's a lot of room for improvement. Thanks for listening. Questions?
I was wondering if there was any way, or if you've seen any form of transfer between categories. And since you're not using traditional collaborative filtering, I'm not quite sure how that would manifest itself. But this notion of this person likes, I like the same movies that this person likes, therefore maybe you can recommend me music that they like.
So I find this a fascinating question, whether preferences cross domains. And there's really very little data to study that question. It turns out that on WikiLens, we do release all of the data that's collected on the site unless people mark it otherwise. And so this might allow us to study this. Now, several of my colleagues were very much less interested in studying this question, so we haven't studied it yet at all. There's some evidence that preferences do not cross domains, not from our data, but from other kind of papers and experiences. But I find it hard to believe that some preference domains which are very close, like maybe books or movies, wouldn't cross at least some. I'd really like to study that further.
Yeah. Likewise. Thank you.
Yep. Well, if there are no further questions, oh, there's a question.
I'm really curious about the spam.
So has wiki spam become a problem? Yes, another one of our lessons that's in the paper, but that I didn't put in the talk because I wanted it to be short, is that our site was open to anonymous contribution, and indeed the Michelob Golden Draft Light page that I showed had mostly anonymous comments. People were being attracted to the site, presumably by searching on Google for Michelob Golden Draft Light and seeing this site and going and begging for this beer. But being open to anonymous contribution meant it got crushed by wiki spam when that started to appear in 2005. We closed the site so that you have to create a login to be able to edit. And wiki spammers even had tools to automatically create logins, which surprised me because we have our own login page. It's not a standard login page. So they must have bots smart enough to identify fields that look like they might be user and password fields and create logins and so forth. So we put in a simple mechanism. You have to rate at least one item before you can edit anything. Since the web isn't covered with sites that allow ratings, none of the wiki spam bots have bothered to cover this case anymore, and we now have no wiki spam. What about human beings basically shilling their own stuff? I just made a movie and I think it's the greatest ever. I should enter it and I should rate it high. Or
I just spam my comment and I read my restaurant.
yes, or there's another restaurant that I don't, whose owner I wish to bankrupt, and I rate their restaurant low, and I create 100 accounts and rate their restaurant low with all of those accounts. So the first thing I'll say is that GroupLens has published a couple of papers on this problem, shilling. And it's an interesting problem. It's non-trivial to combat, and I figured I'd wait until it was obviously a problem on WikiLens before combating it. I mean, right now, I think WikiLens is susceptible to shilling.
Is it because I'm sorry, I'm really
Go ahead.
curious. So you said it's not a serious problem. Is it because the scale is still small? So for example, like
The scale is still small.
motivation of like spamming is not like a significant.
The scale is still small, although in the case of MovieLens, the scale is large, thousands of active users, and honestly, it's not clear to me if there's spam or not. Some MovieLens users think MovieLens is being spammed, but it's very non-trivial to detect whether spamming is occurring. And that's actually a whole different talk. My colleague Tony Lamb has published a couple papers, and I could try to summarize a little bit of how you might detect and effective algorithms. Actually, he's, I think, been more successful so far at describing how you can shill than how you can detect shilling, unfortunately.
Can I send you an email about the pointer about the papers?
Absolutely.
Okay, thanks.
Or you can look on grouplens.org as well. Yeah.
Do you have any thoughts on whether the system will need to be tweaked in any way if the scale for some of the features increases? Let's say suddenly millions of people want to read and rate about beers. Data might still be sparse, but
So does WikiLens scale by the number of users?
what would be needed if we want
It doesn't scale. Not right now. In PHP, it doesn't scale. And again, we wanted to build a system to investigate how these community-maintained recommenders would work. And of course, we wanted to build it to scale, but we wanted to build it first. And so again, this is a very interesting problem, and I think it's important to look at, especially recommendations themselves are probably the slowest part of the site, but we haven't had a chance to address it.
But it seems that you think that most of the problems with scaling might be just the way it's implemented is slower because it's on PHP. But the recommendation algorithm in principle should be scalable, I think.
The recommendation algorithm in principle may be scalable. There are some other features that have challenges to scalability. For example, I showed you that the fields in categories are specified by a wiki page that's editable by anyone. So what happens when you have 100,000 books and you change a field? Does it change instantly on all those pages? Do you pre-compute values? We have the ability to search by a particular field, so you can search for a book whose author is Dan Frankowski. Sadly, that'll come up empty. But what happens, so we use the fields page to generate that search, and we search the fields right now by grabbing the page data and parsing the field out of it. When you have 500,000 pages, that doesn't scale. You would need some way to pre-compute that. So there are definitely more scalability challenges than just the recommendation algorithms. So that's a good question. Yep. Well, if there are no more questions, thanks very much for your attention.